What if your program could decide the answer itself? Imagine entering your age and receiving a different message depending on whether you are a child, a teenager, or an adult. In Part 1, our program collected a name and age, but it gave everyone almost the same response. Today, we will upgrade that program so it can examine information, make a choice, and produce a personalized recommendation. Welcome back to our Python for Beginners series. In Part 1, we learned how to store information using variables, work with basic data types, collect user input, and convert text into numbers. Now, we will use those same concepts to control what our program actually does with that information, instead of always printing the same response no matter what the user types. This is called conditional programming.
People make decisions by checking conditions every day. If it is raining, take an umbrella. If you are hungry, eat something. Python can follow that same type of decision-making process. A condition is simply an expression that Python checks to determine whether something is true or false. Here, Python checks whether age is greater than or equal to 13. Because 16 is greater than 13, the result is true. But if we check whether 16 is less than 13 instead, the result will be false.
Python gives us comparison operators to build these conditions: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Be careful with the equal signs. One equal sign assigns a value to a variable, like age equals 18, which stores 18 inside age. Two equal signs compare two values instead, like age double equals 18, which asks whether age currently holds 18 and answers with true or false. Now we can write our first real if statement. We begin with the if keyword, followed by a condition, exactly like the ones we just practiced. At the end of the condition, we add a colon, and the code that should run when the condition is true must be indented on the next line. That indentation is not optional decoration. It is how Python knows which lines belong to the if statement. In our example, age is 20, and the condition age is greater than or equal to 18 is true, so the indented message runs, and we see you are an adult. But what happens if age were 15 instead, using that exact same if statement with no else block yet? The condition age is greater than or equal to 18 is now false, and since there is nothing else telling Python what to do, nothing prints at all. The program simply moves on quietly. Right now, our program can only speak up when a condition is true. The next step is teaching it what to say when a condition is false. That silent case feels incomplete, so let us give the program something to say either way. We can add an else block to handle the opposite case. Think of it as a decision diamond. Is age 18 or older? If yes, we print that you are an adult. If no, the else block runs instead and prints that you are under 18. Now every possible age produces exactly one message. Two outcomes is a great start, but real decisions often need more than two paths. To handle more than two outcomes, we chain conditions together using elif, short for else if. Python checks each condition top to bottom, in order, and runs the first block whose condition is true. That means the order of conditions matters. Age 10 becomes a child, age 16 becomes a teenager, and age 25 becomes an adult. One chain of if, elif, and else now covers every age you could enter. Before we go further, let us slow down on something that quietly breaks a lot of beginner programs: indentation. Indentation is not just style in Python. It defines which lines belong to the if block and which lines do not. When both print lines underneath our if statement are indented by the same amount, both of them belong to that if block, and both run together whenever the condition is true. But if we forget to indent the line right after the colon, Python has no way to tell what belongs to the if block anymore, and instead of guessing, it stops immediately and raises an indentation error.
This is Python protecting you from an ambiguous program. And the fix is always the same. Make sure every line inside a block lines up with consistent indentation.
Sometimes one condition is not enough to describe what we mean, so Python gives us logical operators to combine conditions: and, or, and not. The and keyword requires both sides to be true at once, so age 15 satisfies age is greater than or equal to 13 and age is less than or equal to 17 at the same time, and the Teen Coding Club message prints. If either side were false, the whole combined condition would be false, and the else branch would run instead.
Python also lets us write that exact same range check as a single chained comparison. 13 less than or equal to age less than or equal to 17, which reads almost like ordinary math and produces the identical result. Either style works, and which one you reach for is mostly a matter of readability. Now we combine everything into the activity recommender. We collect a name and age just like part 1, then use if, elif, and else to choose a personalized recommendation. For Maya, age 16, the program greets her by name and suggests building a number guessing game. Your turn. Add another question asking whether the user likes games, using input just like we did for name and age. If the user is a teenager and enters yes, recommend building a Python game. Otherwise, recommend a different beginner project. That single combined condition, teenager and likes games, is exactly the and operator you just learned put to work. Today, you learned how Python makes decisions using conditions. You used comparison operators, if, elif, else, indentation, and logical operators to transform our simple greeter into a personalized activity recommender. In part 3, we will introduce loops and teach Python how to repeat actions automatically.